Welcome to today's webinar about choosing an AI model, which I'm sure is on a lot of people's mind across various industries. We're all thinking about which model to choose, which one's best, etc. I'm really excited to dig in with you today on that topic. Just to clear out some logistics here, so I'll be presenting the webinar today. In Zoom, you can, throughout the webinar, please put in your questions. You can put in your questions either in the chat window in Zoom or in the Q&A panel. So you should have access to both chat and Q&A. Please put in your questions either to chat or to Q&A throughout the webinar. At the end, Sharon and the team behind the webinar here, they're going to help feed me some of those questions that have come through either the Q&A or the chat, and we'll have time to do a little bit of that discussion. So don't forget, add in your questions. We should have a very interesting discussion today. I'm going to go ahead and share my screen here. All right, so today we're going to be chatting about choosing an AI model, evaluating performance, security, and efficiency. Just by way of introduction, I am Daniel Whitenack. I am CEO at a company called Prediction Guard. The main thing that we do at Prediction Guard is we provide secure private AI platforms or systems to companies that are operating in regulated industries, or maybe just companies that have use cases where they can't send their data to third-party AI systems, like in this case shown on the screen, which is related to both medical, which is sensitive and needs to be private, but also a military application, which needs to be very secure. We also participate in a variety of ways in education, leadership, AI best practices. That side of the puzzle is really important to us. And so even last week, we hosted the first Midwest AI Summit, which was a great success. Thank you. If you're on the webinar and you joined us in person, thank you very much for making that a special event. But I also co-host a popular AI podcast called Practical AI. So make sure and you check that out if you want. We participate in kind of education and partnership with Purdue University and with some other organizations like ML Commons and others. So that's who we are. But we're going to go ahead and get into the heart of the matter here, which is talking about choosing your AI model. As a quick reminder before we do that, we do have a couple other webinars coming up. So if you're not signed up yet, the next one that's going to happen in December is about kind of things that are more than chatbots. I don't think we need more and more chatbots to infinity. So we're going to talk about kind of AI agents and doing things that are not exposed via chatbots. And then later on January 14th, we're going to be talking about AI-driven document processing, which is, of course, very useful. So make sure you register for those. Go ahead and just click over to our Luma page and register for those upcoming webinars as well. So in terms of context for this topic of choosing an AI model, I don't think some of us necessarily need a ton of context here because we are just inundated with news about this model is released and this model is released and now this model does this one and China releases this one and the US releases this one. And it is a very fragmented and confusing ecosystem. Actually, if we look at Hugging Face, which is the main repository of AI models where you can download open weight models, there's more than 2 million models in that model repository now, which is just mind-boggling, right? And this was earlier this morning. There's many more now, I'm sure. But also, as I mentioned, in the news, you're constantly hearing about these different model releases. Like I think this past week, as we're recording this webinar, Google's Gemini program, they released Gemini 3, which is this new model, and you can see here in the caption, it does cool new things, but OpenAI and Anthropic made similar updates. All of these model builders are doing all these updates. And I kind of grayed out the person who posted this on LinkedIn, but I went on LinkedIn this morning and I just searched, how to choose a good AI model. And you see post after post about that look like this. And there's nothing really anything wrong with a post like this. And I'm not disparaging the person that posted it because he is highlighting, the problem that we're dealing with, which AI model is best. But it does add to the confusion. And actually, the model providers, the model builders have added to this confusion. Like he mentions ChatGPT as one of the models or Claude. These are actually not models at all. They're products, which is what we'll discuss here in a second. And so there's all of this confusion. And we really just want to parse through this. Now, in order to do that, what I first want to do is just give a little bit of background information. Like when we say choose a model, what is a model? Now, I'm not going to give a whole history of deep learning is this and machine learning is that, et cetera, but I do want to identify when I say model, what are the assets that are associated with that model? Like, how do I get my hands on a model? And if I gave you a model, what would I need to give you a model, right? And what happens when we have a model is that some model provider has created a very, very large data set scraped from all over the internet of example inputs and outputs. These example inputs you can think of as kind of example prompts, like maybe there's chat prompts and there's code generation prompts and autocomplete prompts and question and answer prompts and all of these, and example outputs. And they curate this very large data set, most of which has been crawled from across the internet. They execute a training process on a model architecture. And that model architecture, it's kind of a fancy word, but it basically just means the structure of the model. So a model is really a data transformation. You take an input and you create an output, and the architecture defines the structure of that data transformation. And so they train that structure and set a series of ideal parameters, meaning that architecture has a set of trainable parameters. And when you train the model, you train that architecture such that it can translate from the inputs to the outputs. And the training is really the setting of those parameters of the model, right? And so this is the training process. And then when we use the model, we execute it in kind of what's often called an inference or prediction mode, where we reuse that architecture, but we don't retrain the model. We just use the ideal parameters that OpenAI or Google or Meta or whoever it is set, and we put in new input, or in another way to put it, we put in a prompt and we get a completion. That prompt might be a text prompt and I might get text out, or maybe it's a text prompt and I get an image out, or maybe it's an image in and I get text out. But whatever it is, I'm really just taking that model off the shelf and I'm executing this inference stage of the model. And so if we look at this whole picture here, we are not the ones that are executing this training process. We're the ones interacting with the model in this inference mode. And there's various portions of this. There's the model architecture, which is written in software code somewhere. That's one asset here. There's the training data set, which is this example series of inputs and outputs. There is the code that's used to train or fix the parameters. There's the parameters, and then there's code that's used to execute this inference process. Now, in order for me to hand you a model, I imagine I've got a little shopping bag, a Christmas gift bag, and I'm going to gift you a model. In order for you to use that model, you would need to have the parameters. You would need to have code that defines the architecture, and you would need to have code that executes this inference. If you have those three things, then you can run the model. So the model is really a combination of data and code. The data is the parameters, the code is this architecture, and the code used to execute the inference process. Now, in order for me to give you the model, I don't have to give you the training code. I don't have to give you the training data. And often we don't get that from the model builders. But that is what a model is. That's how we define the assets associated with a model. So background information, model is code and data. The code is that inference code and the architecture. The data are those ideal set of parameters. Now, let's also then talk about this distinction between model and product, which is critical because if we're evaluating what model to use, it's not always fair if we're comparing models to products, let's say. So a lot of you are, of course, very aware of products like this. I mentioned before, there was that LinkedIn post that talked about one choice of a model is ChatGPT. Well, ChatGPT is not a model. OpenAI creates models, like we talked about before, and they embed them in products. One of those products is ChatGPT, but there's other companies that do that as well. DeepSeek has their own kind of ChatGPT-like product. This is a Chinese company, has their own model. They embed it in a product, right? And so when we look at this distinction, product versus model, actually, there is quite a big difference. So if we take DeepSeek, for example, DeepSeek has a model. One of their models that they released was DeepSeek R1. Okay, so there's a model, DeepSeek R1. There's code associated with running that model. There's data associated with the parameters. DeepSeek has embedded that model somewhere in their infrastructure, and they've surrounded it with a SaaS product that you can log into that's a ChatGPT-like product. And that product has non-AI related business logic, meaning like authentication and, styling, design of the front end, all of these things like that don't have anything to do with the model. They're just part of the product. And that product gathers data as you use it, right? Just like any software product would, whether you're using Salesforce or, NetSuite or whatever, that's going to gather data. And so this is a actual product. So a thing like a ChatGPT or like a DeepSeek ChatGPT-like product or like Claude or Claude Code, et cetera. All of these are products that are software packaged together that have non-AI related business logic. They have the model embedded or calls to a model embedded in it, and they gather data associated with usage. But that's not the only way that you can actually use that model. You could also go to, as I mentioned, a repository of models like Hugging Face, and you could download the parameters associated with the DeepSeek model. You could download the code that's needed to run that. And you could actually run that in a completely air-gapped, isolated environment where absolutely no data flows back to the Chinese company that created DeepSeek. And that's one of the things that we do with Prediction Guard is we create this hardened model infrastructure where you can actually isolate these models and run them completely privately, even all the way to air-gapped. But here, what I'm really trying to emphasize is that as we talk about, quote, choosing a model, really a first step that you want to think about, and we'll talk about that here in a second, is am I choosing a product or am I choosing a model? Because these two things are different. Okay, so let's talk just a little bit about, I know we're giving a bunch of background information here, but I hope a lot of this is useful. I hope you are empowered by this information and this breakdown of jargon to hopefully parse through a lot of the confusing ecosystem of models. So just by way of explaining this, what I'm going to do is I'm going to go over here to Hugging Face. So this is Hugging Face, as I mentioned. This is kind of a main repository of models that you can kind of think about it like the GitHub of models and data. And so here are those, 2 million models that are available to you. But just by way of helping you understand kind of model families, jargon, how those evolve, let's look by way of example at a certain family of models. So if I look at the llama family of models, I can see that these are released from a model builder. Actually, Meta created the Llama models. They created these models, they've released them open on Hugging Face, and I can actually go and see the actual collection of either Llama 3.3, Llama 4, Llama 3.1, etc. So for example, here they've released different versions of this model and different over time as they've further fine-tuned the model, but all of these are directly from the model provider, Meta. And so what happens is Meta will train one of these big models, right? Then they will release it on Hugging Face in a collection like this. So this is what you get direct from the model builder, right? You get something like this. Now, if I look at this, it's going to have a license associated with it, and it's going to have various files. So you can see a bunch of files here that are rather big. These are that data component, that ideal set of parameters as we talked before. And there's code that I can actually use. For example, the transformers library will allow me to execute this model in code. So here I've got the code element, I've got the data element of the model. Okay, Meta releases Llama 3.1, and now let's just look at a few kind of jargon-related things about these model families. So if you notice, there's some different versions of this model, right? We have Llama 3.18b, we have Llama 3.18b instruct, Llama 3.170b, Llama 3.170b instruct. There may be more versions of this, but how you can interpret this is Llama 3.1 is the model instance that I am looking at. So Meta has released version 3.1 of the Llama models, right? Plural. Now, when they release that, they release different sizes of that model. And these 8B, 70B, etc., extensions to that name indicate the size of that model, which is also indicated often in the metadata on the model card. So the smaller models in generally will run kind of easier on smaller infrastructure or even CPUs. The larger models, you may need GPUs or multiple GPUs to run. They are larger. Generally, larger models are kind of have more general purpose capabilities. Smaller models are maybe limited. We'll talk about that here in a little bit, but that's one distinction. So you see those indications here. You also see this extension here, -instruct. So what does that mean? Well, often what happens is a model builder will train a base model on all the data that they've scraped off of the internet, right? And then they will fine tune that base model for specific types of use that they know people are going to want to use that model for. For example, instruction following, right? That's what this -instruct refers to. So if you see something like this with a Llama 3.18b and Llama 3.18b instruct, this instruct model is actually the one that's probably going to be most useful for you to use, because this is the one that they have further fine-tuned based on a curated data set of prompts that they have curated based on how people want to use the model for instruction following, for example. So actually, you can see this reflected in that the Llama 3.18b model has been downloaded 600K times, and the instruct one has been downloaded, 5 million times. Obviously, people are getting more utility out of the instruct. So just in summary, we have the model builder, Meta. They have released a family of models, Llama 3.1. Those have various sizes, and sometimes they have a base model version and a fine-tuned model version that is fine-tuned according to some preference following or specific type of task. Okay, now what happens from there is Meta releases the model, right, the Llama family, but now this is out in the world, and everybody can create their own versions of it and their own derivations of it and their own fine-tunes of it, right? And so if I go to models again and search for Llama, right, I actually see more than models released by Meta Llama. I see ones from NVIDIA, And I see ones from, MLP, whatever, mini core research, etc. And so some of these, like if I search for the Hermes series of models, um, Noose Research will release model families that are fine tunes of certain families of models. So the kind of Hermes 3.1, you could see this, just by way of deciphering this, is a fine tune on the Llama 3.1 model, the 8B version of that. And they fine tuned it further based on their Hermes data set. And this may be because you may want to use this because this particular flavor of data set performs better for certain tasks, or maybe is better than that initial one that Meta releases. But what happens is you get this kind of family, this model family developing and this branching out where Meta releases the initial version, then all of these other folks out there in the ecosystem start fine-tuning these for their own purpose. Some of that is based on their own data sets, but some of that is also to actually optimize the model. So if I look at things like these extensions, so like a GGUF extension, or like a FP8 extension, these are optimizations of the model to run in floating point 8, which is a smaller, more optimized version for constrained environments, or GGUF that I might want to run on like a MacBook or something like that. So this is how these model families develop. This is how some of this jargon works, is there's those base models from the model provider. There's different sizes of those. Those then branch into a family of models, which are fine-tuned for various purposes or optimized for certain constrained environments, like a smaller environment, a CPU environment, or a MacBook environment, or whatever those might be. So hopefully that is a little bit of level setting of this very strange world that we live in. Now, the next thing that I want to do is based on all of that background information, now we actually need to talk about, well, how do we use all that information, combine it together, and actually choose an AI model to use? And I would say there's kind of a step 0 here before we get to step 1, which is you determining whether you actually want to choose a model or if you want to use a product. And I've kind of framed this as a product or using a model with various applications on top of that model. To illustrate this, what I'd like to think about is, well, let's say that I want to do vibe coding with an AI model, right? I actually have a step 0 choice, which is, do I do that vibe coding with an off-the-shelf product, or do I find a model that can do that and use some tools or apps on top of that? So just to illustrate that point, something like a Claude Code here, which is very powerful, it is a pre-cooked product, right? Not only is it using the Claude models, which in themselves are products, productized versions of the models, but it in itself is a product with extra kind of layers of business logic on top of it. It is kind of locked down to the Claude series of models. It has its own, pricing structure, right? According to how you might want to use it in more of a SaaS model or a per seat model, right? And so one choice of me kind of wanting to do vibe coding stuff might be to use Claude Code, which is a product. In that case, I'm choosing the product. I'm not choosing the model. And we'll get to some of the advantages, disadvantages here in a second. On the other hand, I could use something, let's say, like OpenHands. OpenHands is a more open version of a vibe coding type of tool. And the way that they've come up with this is they've treated this as an application that runs on top of your choice of models. So in this case, you would choose a model, and you can actually see here, this is model agnostic, and you can run OpenHands on top of various models, some of which are self-hosted or local, or you can do models from different providers, etc. And so this allows you to then have an application on top of the model of your choice. So why would I want to do either of those things? Let's kind of parse through that. So in terms of advantages, disadvantages on the product side, you get easy access to a SaaS, type model of product model where I just sign up for a per seat cost or usage. It's usually kind of flashy and polished. There's kind of a clear supported set of core functionality because this is a product, right? The general disadvantages are, for the most part, your data is going to go to third parties. Both the data incoming to the product and the data coming out is actually subject to their terms and service, right? Meaning, like, if you're doing vibe coding and the code's coming out of the product, that code that you're generating is tied to the terms and service of that product. And so that kind of creates some gray areas sometimes IP wise. Sometimes there's unclear security. Your data lives at rest in other, third-party infrastructure. Often you get like model lock-in, which is kind of problematic in the sense that models are proliferating everywhere, and who knows who will have the best model in the long run. If you lock yourself into a certain model provider, that might not be the model provider that's the best model provider always into the future. And there is necessarily going to be this kind of limited set of functionality or integrations because they're only going to support what makes sense for their product. There's not as much customization. On the kind of choosing a model plus apps on top of that model, you do get that model family choice. You remain model agnostic. It's completely customizable because you have direct access to the model. If you wanted, you could write your own vibe coding tool on top of the model. Now, in reality, you would likely use something still relatively off the shelf, but you could still customize it. This can be private and secure. It can be locked down in your environment. You can kind of leverage various things from the open source community, but it does maybe have a higher setup upfront cost, potentially involving, some custom development. And sometimes there may be unclear support. Now, with Prediction Guard, for example, we have a robust system to scale up these open source models and their secure use. But that is why we're providing that product, because sometimes if you just get the model, it's hard to, roll your own version of that, right? So there's advantages and disadvantages on either side of this. So this is a first choice you have to make. Kind of choice zero is, do I want to actually use a product, or do I want to use a model plus a set of applications on top of that model? Then you need to make a choice in terms of the efficiency of the model. I'm going to talk about efficiency and security and performance as I go through these things. But on the efficiency side, just to kind of go back and illustrate this directly from Hugging Face, there is this kind of set of models, right? I could decide, oh, I want text generation models, and that's going to filter me down to various text generation models. But you can see there's this range of parameters here, everything from less than 1 billion parameters to greater than 500 billion parameters. And I'm just going to give you a few kind of general rules of thumb that we've learned over time that that may be helpful as you think of the efficiency side of things. If you are needing to run your model not on GPUs, but on commodity hardware like CPUs, or you want to embed that in a CPU-driven kind of application that you're hosting in your cloud environment, or even if you're using like a managed endpoint, like an AWS Bedrock or something like that, smaller models will be more capable of being run on commodity hardware and or will be cheaper to access through some managed service than larger models. Of course, that comes generally at a price of kind of general purpose performance, but I often say in your business, you actually don't need a ChatGPT like interface. Maybe you need a ChatGPT like interface, but not every application. Like if you're building an automation, that takes in a document into one side and extracts out a few things and then sends an email. You don't need a general purpose model that does a bunch of other stuff. You can do that perfectly well with a small model. And so these task specific things that you need to do, they are perfectly capable with a smaller model that will be cheaper from a managed side, and or if you're hosting that, will be cheaper from an infrastructure side. And if you're wanting to run that on commodity hardware, I think if you shoot for something less than 3 billion parameters, it still sounds like a lot, 3 billion, but that gets you something that's very workable even to run on your laptop or to run on a CPU, at least if it's a later generation CPU. Then if you go up a little bit, you know, maybe up to kind of the ideal range, kind of 7 billion parameters or maybe a little bit more. That's going to run really well on a single GPU card often. And that could be a more commodity GPU card or a cheaper GPU instance in the cloud. So you could restrict yourself to cheaper GPU instances. As you go up kind of to the 32 billion parameter zone, now this may actually fit on a single card, but it's going to have to be a later generation GPU, a much, much higher performance GPU, much, much more memory, or multiple GPUs. And then as you go beyond that, you're necessarily having to run this across a kind of cluster or multi-GPU setup, which gets, more complicated. And so this is kind of the efficiency constraints that you want to have in mind. Now, those efficiency constraints might be driven by your cost constraints, like you don't have a lot of budget, right? And so you want to use a smaller model because those costs are going to be cheaper. It could be due to the environment in which you're deploying, right? You need to deploy this on a customer side or at the edge where you need a smaller model, right? And you need that to run on CPU. Or it might be due to kind of throughput constraints, like I need to scale this over multiple GPUs or have multiple replicas of it because I expect a lot of load on my system. All of these things can come into play, but it's really this kind of size of the model that can dictate that efficiency. Once you dig into that, there are a variety of kind of additional optimizations that you can apply. You can look at, for example, work by Neural Magic. Neural Magic. I'm not searching the right thing, but they have great optimizations, GGUF optimizations, or FP8 or FP4 optimizations can get you down a little bit further. Okay, so that's the efficiency side of things. Let's talk about the safety side of things. So actually this safety side is quite interesting, the security and safety side. So some models are going to necessarily be more biased to misbehave, let's say. So we all kind of know at this point that model usage can go very poorly in terms of the security side of things. You can have malicious inputs like prompt injections. You can have jailbreaking where people try to get your AI system to do things that you don't want it to do. You can have sensitive data disclosure where sensitive data is output from the model. So there's all of these sort of security or safety concerns related to AI model usage, and not all models are created equally in terms of this security or safety usage. And so what we have to do in order to probe this side of things is you really want to leverage some kind of model scanning technology, which would allow you to put in essentially kind of or execute this kind of automated red teaming type of procedure where you would put in problematic inputs into a model or into a set of models and then see, do you get problematic outputs or does the model refuse to do the problematic things, right? And you don't want to just do this once, you want to do this many, many times. So you want to have a bunch of problematic inputs. You want to probe the behavior of the model, and you want to see if there are refusal or problematic outputs, et cetera. Now, one key thing here that makes this a little bit difficult is actually it's very important for at least a portion of this data set that you're using to probe the problematic behavior of a model. At least some of this needs to be private. Why is that? Well, the reason for that is if you release data publicly, that's just going to be sucked up by all these model builders as they train their models, and those models will be overfit to the data that you're hoping to test the models on, which means it's not a kind of good test of the specific model. So you have model builders that are essentially gaming the system, either intentionally or not intentionally, because of the data that they're sucking in. And so unfortunately, some of this needs to be private. Now, in Prediction Guard, we have our own model scanning capability. I'll show you some results of that here in a second. But there's other model scanning functionalities. There's open source versions of that. And you could create your own version of that if you're concerned about particularly problematic behavior in certain areas. Create your own test set and probe at different models for their response there. Let me pull up this here. This leaderboard here. So from our own model scanning functionality, this is just how the output of some of that might look. Thanks to one of our engineers, Ashwarya, who put this little data set together and tested a few models ahead of this webinar. But what's interesting is we tested a few models from different model families and continue to test more. But we actually had a public data set that tested for things like prompt injection, and we have an internal safety test for these models here at Prediction Guard. What's interesting is if you look at kind of on the public data set, something like OpenAI's GPT-OSS model, which is an open source model from OpenAI, it actually gets 98% rejection on jailbreak attempts. In other words, it rejects 98% of these kind of potentially malicious inputs. However, on our private safety test, it actually only refuses 25% of the malicious inputs. What does that mean? Well, it means that OpenAI is definitely overfitting on the public safety data that's out there. And this number does not accurately represent how the model might behave in your own enterprise setting, which is why, again, it's important to have that private safety test. The other thing is you can see basically OpenAI GPT-OSS, it refuses a lot of stuff, even things that are not problematic. And so this benign question refusal means these aren't malicious inputs at all. It just still refuses them. So it's kind of one of those things, if I refuse everything that's coming into my system, then I'll get the malicious stuff, but then I still can't use the thing because it refuses all of its inputs, right? Whereas if you look at something that's coming out of China, like a Quen model, it actually has the highest jailbreak refusal rate and the lowest corresponding benign question refusal. So Quen is actually more discriminative in terms of refusing the problematic malicious inputs while letting the non-malicious inputs pass through. There's a lot of interesting results that can come out of something like this, but you really need some kind of model scanning functionality like this and you need to run that kind of in a private way to really get a sense of how safe these models are to use. Okay, the last thing that I'll talk about is choosing an AI model in terms of performance or quality. And I also just realized all of my steps are step one. So I'll change that in the slides afterwards. But the last step here in terms of performance or quality is Now that we know we have a model that we can run efficiently, we know we have a model that is safe and secure. How do we run that model, or how do we know how that model will perform in terms of the quality of the outputs of the model? So here, what I always encourage people to do is not directly go to a public benchmark for the same reasons that I talked about in relation to the safety side of things. The model builders have access to those benchmarks, and so often those benchmarks are gamed, either intentionally or not intentionally, and they don't really represent the reality of your use cases in your business, how you want to use the model. It doesn't really equate to those public benchmarks. And so what you need to do is, and this is kind of pulling from my data science roots in my previous life, is you really need to set up a kind of behavioral testing system. And the way that I describe doing this is to think of every place that you are calling a model in your system. That could be in your low code, no code automation. It could be in your custom code, whatever that is. Think of every place you're calling a model, and that will often be multiple places, right? So you're calling a model once to extract this from a document. Then you're calling a model another time to summarize that from the document. And then you're calling another model to write an email with that information, or whatever those things are. So actually, to really robustly test the behavior for your use case, you need to split out the functionality and understand where you're calling the models. Then for each of these model calls, for each place where you're calling a model with example input and output, you need to create a set of what I call table-driven tests. This is all I mean by this is you have a set of inputs. It could be in just a Google Sheets document, or it could be in a table-driven test that's in your CI/CD system. But you have a table of tests, and for each of the rows in that table, you have an example input and you have an expected output. And you want to put all those example inputs into your LLM or AI system and actually measure if the outputs align to your expected behavior. And you really need to automate this. That way you can test various models against your specific table-driven tests. And I always recommend to people that your table-driven test should include minimum functionality tests, meaning this is like the bare minimum behavior of the model. Like if I'm using the model to detect, let's say, a sentiment in incoming text, and I have something that says, "This is great. This is the best thing ever. I love this. So good." I should never label that as negative. If I labeled that as negative, that would be a failure of minimum functionality, right? And then you have kind of invariant and variant perturbation tests that essentially allow you to test if I change something about the input, does the output change or not change in an expected way? So just to give some examples of this, I mentioned sentiment analysis. So maybe you have an input, you have an expected output that's maybe a class or a word representing the expected sentiment, and you could check for an exact match there. For minimum functionality of something like translation, maybe you're just testing with a language detector, and you don't even care the quality of the translation. You're just testing that the output is in German, let's say, if you're translating from English to German. And then in terms of knowledge-based things, maybe the minimum functionality test is asking a question and not checking everything about the answer, but just making sure that particular key information is in the output, like in a substring. In terms of invariant perturbation tests, you want to check, if I change something about the input and I don't expect the output to change, then do I see any change in the output? So maybe this is introducing misspellings or different phrasing into the input, but not expecting the output to change. Or maybe this is, putting a different language in the translation input, but still expecting it output in German. And then you have variant perturbation tests where you change something about the input and you necessarily expect the output to change. So things like negating in the case of sentiment, or putting something into the translation like code and expecting it to not come out in German, or in the chatbot changing the knowledge and expecting something to change in the output. So these are all ways that you can use these table-driven tests to really probe the behavior of your model. Once you set up these tests and you can run them in an automated way, you can, number one, use these automated tests to check a bunch of different models from Hugging Face or from different providers to see how well they perform on your task. And you can then make sure that you don't regress over time. So let's say you want to upgrade from Llama 3.1 to Llama 4. You have this automated test then to help you know if you're going to regress in your behavior. So that's all I have for you today. Just, I know that was a lot all at once. Please join our Discord if you want to chat with us. That's free to join, or happy to give feedback and be a sounding board. I do have a blog post here at predictionguard.com about kind of decoding some of this model jargon. And please don't forget, please sign up for these upcoming webinars about kind of going beyond chatbots and AI-driven document processing. We would love to see you there. With that, I'm going to stop sharing my screen and look over here to see what questions have come up. So, all right, we have a few questions that Sharon has popped through. I'll address as many of these as we can. The first one is the architecture, the math that creates the models and the outputs. So it has, there's math that governs that architecture. But if I were you, I would think about it just as a data transformation. So if I have data coming in one side of a data transformation, I must have logic to transform that into output. So if I'm doing object recognition, a picture comes in one side and a label comes out the other side. Or if I'm doing text generation, text comes in one side and a prediction of a next word comes out the other side. And internal to that function defines, I'm going to take these pixels of the image and multiply them by this number, and then I'm going to put that into this sub function that multiplies it by this number, and all those coefficients of how that data is transformed are the parameters, but that structure is the architecture, which often is defined by this kind of neural network architecture. Second question, how should an enterprise prioritize models based on their license restrictions? Great question. You'll see in Hugging Face that there are various licenses that people use for models. On one hand, people use data licenses because there's a portion of the model that is data, like Creative Commons. Other people use code licenses like Apache 2 or MIT because there's a code portion. Others just create their own custom license, like what Gemma from Google does or Llama from Meta. So unfortunately, the answer that I have to give you is you really need to look at the individual license of the model and make sure that the use restrictions of that license align with your use case. So for example, the Llama model has a use restriction for kind of industrial and military purposes, I believe. So if you're in that industry, you shouldn't be using that model for those use restrictions. Other models like Unbabble's Tower model, it's only can only be used by non-commercial usage. And so if you're using it to make money, you can't use it. And so you really have to kind of filter down your potential model choices based on that license early on. Which might be the best open source multimodal model available? Right now, at least as far as our experience, the Quen models are pretty stellar and surpass most others. They originate from Chinese model builder. They are really great vision models and do excellent at kind of multimodal tasks, at least from our experience. There are others if you need to avoid that kind of either perception or restriction around kind of getting them from China. There are ones like the Gemma, the more recent Gemma, or there's some fine tunes from NVIDIA that are multimodal, but most of the Quinn models are maybe a little bit higher performing. Um, how should organizations think about long-term model family lock-in and when it becomes risky? Great question. I would say that long-term model family lock-in is risky. So I wouldn't really put it as is it risky or not, or when does it become risky? I would say if you are locking into a model family, you are introducing risk, and you should think about how you can be more model agnostic in your strategy. For smaller enterprises, what is the minimum viable setup for secure and efficient self-hosting? We have customers that are running the full kind of AI platform stack that Prediction Guard provides on CPU or even single GPU instances. I would say if you're a smaller enterprise, um, you know, and want usage across your enterprise, at least having one GPU in your cluster or in your setup is very useful just in terms of efficiency and throughput. But that could be a lower, tier commodity type GPU, not um, the highest, most recent GPUs. And then is there hardware GPU slider on Hugging Face or another platform? There's not really a hardware GPU slider on Hugging Face because there's just such a wide range of hardware that people could use to host these models, which is why they put that slider for parameter size, because that does often correspond to how well that model can be used on kind of more constrained hardware or less constrained hardware. Um, Unfortunately, that is a very complicated, answer to give on if I have this mix of models, what hardware should I have? From our perspective as a platform provider, we have a lot of those kind of hardware configurations and recommendations kind of baked into our system, and that's part of the value we provide. Because it is honestly, it's just a lot of variables to consider. So there's, at least as far as I know, there's not kind of that level of slider anywhere. Um, let's see. Curious about the name Prediction Guard and your background. Yeah, thanks for the question. So my background is originally in physics. I did a PhD in physics and then moved into industry around 2011, 2012. When kind of data science was booming. I worked as a data scientist at some startups and then an international NGO, and founded Prediction Guard out of that. In terms of the name Prediction Guard, I knew that enterprise environments were complicated, as we were talking about, and people needed secure private ways of managing and deploying models in those environments. And I'm not a branding expert, so I just generated a bunch of names out of an AI system. And then I found all of my friends that work in enterprise environments, and I asked them which of those names kind of seemed to make sense to them. And Prediction Guard was the name that made sense. So that's what we chose. Let's see. I think that was the last question there. Looks like we're getting done close to the hour. Thank you again, everyone, for joining. I really appreciate you spending time with us today. Like I say, make sure that you register for the upcoming webinars. Thank you for the questions and spending time with us, and hope you have a good rest of the day.